Okay, so I'm going to move on now. There were some questions that Graham and I posed a bit earlier today at the end of the first session, but we've also had a few that have come in from people in the audience. So especially, I want to come to this one that we've been holding on to since just before the kind of main break, which is, I'm going to move some things around here so I can see what I'm doing. We can see there is the fourth bullet, or hopefully you can see on the screen now. Uncertainty will be transferred across the energy vectors along with flexibility as the vectors are coupled. I mean, it's what we've been talking about all day. But here's this big question, I think. What will be the impact of such an increased uncertainty on the reliability of supply? So I'm going to invite our panel here to have the first go at answering some of this. So Pierluigi, you were saying you've got a bit of a something you'd like to comment on that one.
Yeah, no, thanks, Keith. Yeah, I'll start with that. I think there is obviously a trade-off there. There is uncertainty, means that there is more risk, especially if we do not understand, as I'm talking about power system engineers, exactly how these other energy systems work in detail. However, I believe that there is a lot more to gain in terms of flexibility than to lose in terms of risk and reliability. Actually, I'm pretty confident that going forward, we'll see there is a more and more value in try to couple more the systems and optimize in a better way this coupling of the system, including for provision of different kind of reliability and security services.
I mean, one of the things that I think maybe a challenge is just in the way we frame the problem is, you know, in power systems, we've been maybe thinking in generation adequacy studies, let's say, that demand is sort of a given. And we then are looking to build enough generation to meet that demand with a certain probability. But actually, when demand is flexible, it's no longer a given, is it? So how can we really take account of that? And in particular, when the flexibility is enabled by some of these things in the other energy vectors that we've been talking about.
Yeah, absolutely. I mean, the way that we're doing this kind of modeling is indeed to try to couple more and more both physical aspects and economic aspects. So in a way, it's like trying to bring also sort of market-related issues into the kind of adequacy studies that you mentioned. Additional to, of course, the coupling of the other energy sectors that is sort of the starting point of that. Obviously, there is a great complexity associated with that, but you know that is just the way we're going to. As you said, this idea that things are given, fixed, and then we do a simple Monte Carlo simulation of that for adequacy studies. I think it's gone forever, basically.
So we've still got Misha, Alex, Vittorio, and Elisa on the line. You know, Joe is still present. Any of you want to say anything about that? About, you know, reliability of supply, how we value it, how flexibility in one vector impacts on delivery of service in another vector?
Well, in the case of thermal networks, I think you can more or less take advantage of the of a large flexibility. I mean, if you want to modify the amount of energy or thermal energy you are supplying to an end user, you can basically do it considering time frames of the order of 15 minutes, more or less, without affecting that much the feeding by the end user. So generally speaking, the inertia of the thermal network is sufficiently large, especially when considering large systems.
Yeah, so that seems pretty good up to 15 minutes, but I guess maybe to be of real value to the electricity system, we might want some flexibility on a longer timescale than that. I mean, one of the big challenges, it seems to me, is we have a system that's more and more reliant on, say, wind power. We have a wind drought where the wind speeds are very low for a period of a few days or even a couple of weeks. Is it possible to sort of value, a value of lost load, and then how it impacts then on end service of delivering heat or delivering cooling, for that matter?
Well, it's possible to further enhance it, considering physical thermal storage units, for instance. Well, in this case, you can significantly enhance the system flexibility. The previous number was just performing somehow sort of demand side management at the building.
Yeah, Misha, I think you were going to say something as well.
Yes. Maybe putting it in a little bit other perspective. So you may ask what, in terms of techniques and in terms of how to estimate reliability, how to put it all in a context of statistics and introduce, we have quite a lot of languages for that. So it's not a big deal. We can use all of that. Question is, of course, more about who will be driver for those changes. So I do believe that drive will come from distribution, from smaller scales. So basically, a really ultimate link between all those different energy vectors is at your home, right? And then if you'll balance it and if you'll make a decision based on what is available, and of course it will be economic decisions, then it will start to proliferate. But sooner or later, we'll get enough of aggregators who will be basically more or less estimating those risks and mapping it into money, and then it will elevate to system operator. So basically, in experience I had so far, so big power companies, big gas system operators, they're not really, they have a good, reasonable status quo. So drive will most probably not come from them unless governments will start changing it. But will be, well, it's economy of scales, right? So all those are small contributions, small changes, but they sum up, and a lot of business opportunities. But again, it's not an issue of that we don't have language to describe that. We do have all possible kind of mathematical tools to work on that. And power system is probably most advanced in terms of using those tools. So push will probably come from folks who are doing it in power system.
Yeah, I mean, what you mentioned there about aggregators and kind of business, and there's a comment that's been posted on the Q&A by actually my colleague from Strathclyde here in Glasgow, so Ivana Kotska, who is saying that it's a question of who bears the risk and how that affects operation and business models. In particular, those of aggregators are often seen as crucial for management of flexibility. And I think we've seen some of that in the British market. I'm not sure about other markets where we have the retail sector has been opened up to competition at a domestic level for quite a long time, but it's really seen, I think, very little innovation until recently, when it's some of the newer companies that have been coming into that space have been much more imaginative and are being much more bold about seeing value in some of that flexibility.
Yeah, it will be a risky business for aggregators, but it will also be, it will lead to profit. So basically, they'll need to learn to use this, mapping of risks into pounds or dollars.
Yeah, and I wonder if this links now to if you can still see these further questions on the screen. The fifth point there, where I was struck by some of Alex's modelling, I think it was from earlier, and modelling of utilisation of the kind of the thermal inertia, I suppose we could call it. and how actually the energy paid back was less than that was discharged. But that model, I guess, Alex, didn't explicitly take account of the impact on comfort or the delivery of that energy service.
Well, actually, I think that example was from Pierluigi.
Sorry, Pierre. I'm sorry.
But,
so if it was a good example, you were going to claim credit, and if it was a bad example, you're going to say it was Pierluigi's.
I was actually very happy for Alex to answer the question. So, Alex, feel free to answer.
Well, I think it also links a bit with reliability a bit, because from the side of heat, we know that we don't have to provide the supply all the time, and it's going to affect comfort, but customers wouldn't just lose all the heat. They would just not have the temperature that they want. And I think it's something similar for reliability now that we start having more flexible customers, because some customers may now have the capabilities to self-supply, whereas others do not. So so far, at least traditionally, we have been just assuming that whenever we lose the supply, the customers would be disconnected. Whereas now, as they start having this flexibility, it becomes something similar to heat. They can basically self-supply a bit, and the impact becomes a bit more social, and also socioeconomic, because the customers who have the most resources would be the less affected by this type of impacts, whereas the ones who don't have the resources to install the technologies would actually still be behaving like traditional customers who would just be disconnected. And I think it is very similar. So it's going to start becoming a bit more social. We would need to understand how this affects them.
It becomes a bit sort of nuanced, doesn't it? Kind of shades of grey. It's not you've got a supply or you haven't. It might be part of your supply is there, or if it's energy as a service is being talked about as a commercial model as well. It's a lower temperature rather than the higher temperature that you might want. Although how long that lasts, then it has potentially really big social effects, doesn't it? The value of that lost load becomes very high, doesn't it?
Yeah, and something that I wanted to highlight also was that the response of people would change a lot. I'm thinking, for example, I've seen interruptions in, let's say, some Asian countries, and people don't mind. They just wait it out. Whereas you would have cases in Australia where people don't like the low reliability, and they're starting to invest more in becoming self-sufficient. So even people react differently to the same type of events.
Yeah. So Ivana's come in with a clarification on that. Ivana, would you like to say a few words on this? I can give you the microphone if you want to do that. And so I've given you the microphone, and if you're happy to talk, just unmute yourself, because I know you're making some interesting points about who bears the risk and penalties for non-delivery.
Mm-hmm. Yes, the question which has been raised quite often or is circulating in the community is really when we anticipate the delivery of flexibility that we anticipate it is going to go through the aggregators or any other kind of a organization which is going to deliver that. If they're going to see high penalties for non-delivery of flexibilities, then it might be too high for them. And then they might really lose everything that they can earn through other times. So that is one of the questions which has been seen going on as a question in the community. Who really and how much will the non-delivery of flexibility that was promised will be penalized? Because we have to be careful. If we kill the aggregators, whether we will be able to deliver what we actually need. And non-delivery, on the other hand, for the system operators can be really a big deal.
Yeah, it's a serious
so how
thing,
to balance, So how to balance this in a sense of really, getting the proper flexibility and having the aggregators feeling the responsibility that they need to deliver what they promised. On the other hand, very often aggregators are really depending on their customers. So really putting everything in this business model so that they can earn some money, they can make a profit, that they don't really just go bust quickly. I think that is something that we need to think of carefully and to see, yes, they have to deliver because system operators depend on them, but on the other hand, if they go bust, there is no one else who is going to deliver. And if aggregator businesses are starting to see that the others were not able to provide, or actually to earn any money there, then we are going to lose really the complete community, which we are actually depending on.
Yeah. Okay. Thanks. I mean, Misha, I think that thing about non-delivery, I think from what I can remember, was noticed in that polar vortex. I think you showed a brief example of that. PJM, I remember, for a few years, were being very proud of how much demand-side response they had in their adequacy market. And then when it was really needed in the polar vortex, it didn't deliver. And I mean, it's perfectly understandable, I guess, if a lot of it was air conditioning load in summer rather than heating load in winter. And then, as I understand it as well, that after that, as a learning point was revising the contracts to put in much stiffer penalties for non-delivery.
Well, it's kind of a rhetoric question, yeah. So it's how to set market or for that matter regulations. That's an interesting and big challenge. So on delivery, should it be punished? Should it be not? And at which scale? And who is taking the bill in the case of these emergencies? So all of those questions, they're not specific to gas or power or district heating, right? So we may come up with tons of solutions, but back to this aggregator issue and kind of asymmetry. So there is this approach in US considering on the power side, considering aggregators as a kind of on the same footing as a normal power plant, right? And there is a lot of criticism, but for that, like it suppresses them and not much of a business opportunity, but it is some rule, and they certainly can, some aggregators can operate within those rules, some not. I guess all of those degrees of freedom people are mentioning, those are valid points, and we just need to have good, interesting business cases, people who are willing to exercise this risk. And yeah, so to be ready to pay not only in the case of success, but also in the case of failure.
So there's an interesting point that's now come in on the Q&A to do with this co-optimization, and I think David Pozzo is suggesting that there might be cross-subsidization between energy markets, and if I'm interpreting his question correctly, maybe there's an issue. Well, I feel there's an issue anyway about, if you're a customer or an energy user who isn't able to be flexible, and it might be for some social reasons, are you then at risk of being sort of punished and having to pay a lot more? And maybe someone who's can't be flexible is a vulnerable elderly person, or someone who's a home carer or something like that. So maybe this is two things. There's one is cross-subsidization between energy markets. Is that a danger? Is it a bad thing? And then the other point about if you can't be flexible, are you then somehow being punished, and might that disproportionately affect vulnerable energy users? Who wants to have a go at that one?
Well, I can try to answer, and yeah, David, good to see you around. I think we need to start from a kind of physical constraints, right? Because this lack of delivery, or most expensive part is coming from that. So when city gate is basically not supplied, or when so you basically cannot deliver, and then we need to put all of that in one big model, right? A model with constraints, and put it in a kind of in the language of optimization. So how realistic will it be? And then so come up with market solutions. I guess you yourself, I'm talking now about David, more or less been discussing quite a lot planning on a power system side. So it's probably most challenging power system problem. So you're already familiar with quite difficult optimization. So it will be even more difficult, but more or less along the same vein.
David, I've just given you the chance to speak if you want to. Do you want to say what you think about this? If you unmute yourself, if you're willing to do that. Or if you'd rather not, that's fine. I mean, don't insist. And also, I mean, I'll just come back. I mean, I think that original question about reliability was posed, yeah, before the halftime break by actually another colleague from Strathclyde, Wakas. Wakas, do you want to see whether we've succeeded in answering your question, or you got some comment you'd like to make? I've caught people by surprise, perhaps, by saying, "Hey, you have the right to speak." And I'm conscious as well, we're coming quite towards the end of our allotted time. Okay, so maybe we'll try and just ask a last question to our invited speakers from today who are still with us. So Misha, Pierluigi, Alex, Vittorio, and Elisa. We've talked a bit about business models there, and we've talked about how some of this modeling can be really useful. Just maybe a couple of last comments about who have been the kind of customers for your modeling and who you've been beginning to talk to, because, you know, it's a little bit of making potential users aware of what this modeling could do for them. So who are the people you've been talking to who you think can use your models? And we touched earlier on some of the data challenges. How do you think we can address some of the data challenges? So just very brief, a minute or two each of you, please. Misha, just to have a first go at that.
Well, I think probably the most interesting case in terms of getting traction with system operators on the energy side, not on the power side. I think Vittorio probably is the best person to answer that, because this example of Turin is quite impressive. So what I'm trying to do on the US side is start from a distribution level and kind of campus level. And I think university campuses, they're interesting examples of small hubs, energy hubs. And some university administrators are quite, I mean, again, on the yes side is quite interesting. Stanford was interesting and, I mean, proactive. Well, I'm in Tucson and we have, well, basically air conditioning situation entire summer. It's a big university campus wide, one big air conditioner. And I'm trying to convince them to do kind of demand response type of analysis and studies. And well, but I don't have much of a success on that yet. But that's, I believe, should be coming, yeah, again, from a relatively small scale. Yeah, and I'm sure Pierluigi also has quite a lot to say based on the Australian example. Australian seems to be quite good in that, right, Pierluigi?
Yeah, absolutely. There is lots of interest in these ideas of, well, as a matter of fact, we are sort of planning now the new engineering campus, University of Melbourne, that sort of be built as a multi-energy virtual power plant, exactly to do the kind of demand response that you mentioned for the Stanford campus. I mean, the engineering design will look actually very similar with this kind of smart thermal loop for heating and cooling that exists in Stanford. But yeah, we're planning to have all the sorts of grid services from this multi-energy coupling. But addition to that, I wanted to say that in terms of users of the modeling, here in particular, we are working very close to the gas industry, because hydrogen is very big in Australia, at least in terms of interest. And we've been working with gas industry to develop the models of the gas networks, so that to understand what will happen when you start injecting hydrogen at scale. And so far we've developed a model of the whole gas network in Victoria, and we are studying injection of hydrogen at different levels of the network. And we're planning to do that for the whole Australia. And this is really supported by the gas industry. And thanks to them, actually, we were able to collect all the data of the gas network. And I mean, it's been incredible cooperation. And it's true, without working so closely with industry, it would be impossible actually to do this kind of novel modeling, because besides the equation and everything else, data is so crucial. So that's certainly a great plus.
Yeah, great. Good luck with all of that. That sounds fantastic. And Alex, anything to add? Your experience? Again, just very briefly, please.
Well, for us, it's been mostly state agencies at some universities, including our own. There's also a lot of interest from the network operators, but mostly on knowing how this would impact their networks. So rather than using the models themselves, they just want to have someone else using it to predict their demand. And there's also some interest from local authorities as they're promoting energy efficiency through whole energy or multi-energy approaches.
Yeah, great, thanks. And Vittorio, yeah, as Misha said, you got some great examples in Torino, and I guess you're able to pick up some of the data. I mean, is there a need for more monitoring to improve the data, for example?
Well, yes, in Torino we were lucky to be able to interact with the local district heating company. They are monitoring actually most of the buildings connected with the network. So we have access to the data associated with the energy transfer at the buildings, the mass flow rates, temperatures, etc., and some data on the network side. So there is a quite a big amount of available data, and they are planning to use it, to use this data a lot to monitor the operation of the network, for instance, for preventing falling, but also to propose the end users some variations in the profiles. So there is a lot of work in this area. I think in the next future, as they are generally interested in understanding the possible installation of heat pumps in networks, there will be it will be important to be able to model both the electric grid and the district heating at the same time, in order to take advantage as much as possible of power to heat, power to cool options.
Yeah, excellent. Thank you. And Elisa, just some any remarks from you on this? And for example, with having the monitoring of the energy use by individual buildings, is there the potential to work with some of the people who specialize in modeling the buildings themselves about calibration of their models? You can see how much energy they're using, and then they compare with how much energy they thought the building would use when designing the building.
Yes, sure. This is a possibility. Actually, we need just to remind that in case of district heating, we are dealing with a large amount of buildings. Therefore, it's quite challenging the point related to the building modeling, since we don't have a lot of data available. It's in our case, a crucial point is the installation of indoor temperature sensors that currently are not available, and that from the viewpoint of the company, it is currently not possible, since they have like power to operate until just on the district heating network and the substation, but not on the building. So I think that yes, there's a lot of work in this field, but it's quite critical because it includes something that it's not on the control of the energy agency.
Yeah, right. Yeah, thanks very much. Well, look, I'm sorry, we've gone 7 minutes over our appointed time for this session. I want to give you a break before the machine learning roundtable. I want to thank once again all of our presenters from today, and thank you for sticking around for this discussion. Many thanks as well to all of our attendees. Again, I can see quite a lot of people are still here, or at least they're still logged in. Maybe they just disappeared and are going to come back for the machine learning bit. Anyway, thank you very much. I've put up a few next steps. I mean, these are kind of similar to what Pierluigi had thought of, and I thought of. We did a survey paper in the PSCC in 2016, wasn't it, Pierluigi?
Yeah, it was.
So I think a lot of these challenges still stand, don't they?
Absolutely. Yeah.
As well as the ones we've just been talking about. So I think there's a lot to do. And this is why I think this is a really important and growing area. And I would come back to that kind of fundamental challenge of changing the way we use energy in order to reduce the emissions associated with it. So yeah, I'm not sure there's much else we need to say just now, Pierluigi, is there?
No, absolutely. I think we're done, and I just want to thank you, Keith, and everyone. I think it was really good. That's my view. Hopeful that everyone enjoyed.
Yeah, so I'll just recommend again. When was your session on multi-energy systems? That's on Thursday?
Thursday evening, yeah.
Thursday, quite late. I mean, very late for you, I think, isn't it?
No, for us it's early morning actually.
Oh right, okay.
Yeah, so it's a bit. No, but it worked. It should work pretty well.
Right, and also I'll commend to you that the panel session on Friday. Again, we'll be looking at some of these practicalities of taking research out into application, and we have a couple of one current academic who's been successful in building up a business around a particular model that grew out of his group. Another academic who's trying to sort of start a spin-out company, and then two people with an industry perspective. One is a TSO who wants to use new methods, and the other is a big manufacturer who again is looking for new ideas. So yeah, hopefully come along for that session as well. So that's it. We'll wrap up this. Thanks very much again. 20 minutes time, the machine learning roundtable will begin.